The Mandelbrot set, one of the most recognizable fractals of modern mathematics, is a visual and mathematical representation of chaos and order. The set arises from a deceptively simple formula z equals z squared plus c, where z and c are complex numbers. By iterative application of this recursive equation, and observing whether the values remain bounded or escape to infinity, the set reveals a mesmerizing structure of infinite complexity. It is a cornerstone in the study of complex dynamic systems, which is part of the broader study of dynamic systems in mathematics. It represents a boundary between stability and chaos in the behavior of the sequence generated by the equation. This fractal, with its intricate patterns and self-similarity, has captivated mathematicians, scientists, and artists alike, serving as a window into both pure mathematics and the natural world. The Mandelbrot set continues to inspire research in mathematics, computer science, and applied sciences. High-performance computing and real-time visualization tools have enabled the exploration of ever deeper zooms into the set, uncovering endless layers of intricate detail. The Mandelbrot set, a fascinating construct of mathematics, bridges abstract numerical theory and tangible real-world phenomena. Its intricate, self-repeating patterns mirror the complexity and beauty found in nature, making it a profound example of how mathematics underpins the physical universe. The fractal nature of the Mandelbrot set displays structures that repeat at every scale, reflecting patterns observed in natural systems. The jagged edges of the Mandelbrot set resemble the irregular, self-similar outlines of coastlines and mountain ranges, where the level of detail increases infinitely upon closer examination. The branching structures seen in trees, plant leaves with a cardioid shape, and river networks echo the recursive patterns of the Mandelbrot set, revealing how nature uses simple rules to generate complexity. The Mandelbrot set emerges in systems that exhibit chaotic behavior, providing insights into phenomena that appear unpredictable. The dynamics of weather patterns, such as waterspouts or cloud formations, often show fractal characteristics similar to those in the Mandelbrot set. As the Python script visualization of zooming into the Mandelbrot set unfolds, the viewer embarks on a mesmerizing journey into a world of infinite complexity and beauty. The script brings the mathematical elegance of the Mandelbrot set to life, translating abstract formulas into vibrant visuals. Each pixel of the rendered plane represents a point in the complex plane, iteratively tested to determine whether it belongs to the set. Points inside the Mandelbrot set remain in stark black, highlighting their stability amid the chaos of divergence surrounding the iterative grayscale overlay of the fractal with shades to accentuate the mathematical depth. Each frame draws the viewer deeper into the fractal, unveiling an endless tapestry of spirals, tendrils, and miniature Mandelbrot sets, echoing the infinite complexity encoded in the simple formula. Through this blend of mathematics and art, the script transforms the abstract into the tangible, offering a visual exploration of the universe's hidden order. Whether in science, art, or nature, the Mandelbrot set serves as a universal symbol of the infinite beauty embedded in the fabric of reality. The following Mandelbrot set fractal zoom animation sequences showcase the exploration of the Mandelbrot set, emphasizing varying levels of detail achieved by adjusting the number of iterations. Grayscaling is applied to highlight finer details as the iteration count increases.